Well, thank you, Lee. Appreciate that. Good morning, everybody. You can't test quality into your systems. Anybody else notice the other vendors that were down the hall? When you were coming in here, we had a walk down here. Did you notice some of the other people? Interesting groups, right? We had, anybody see the big ball they had last night next door? Everybody dressed up, tuxedos, black dresses. Anybody see that? Somebody I was having dinner with said, it looked like an old people's prom. I was like, wait a second. That's me. Shoot, I could have been there. And there was Wind River down the hall as well yesterday. Scary looking bunch. I'm glad we're upwind from that group, not downwind river. But yeah, so it's great to come out. I'm going to talk today about you can't test quality into your systems. How many times have we heard that? How many times have we said that? I know I've said it. You can't test quality into your systems. So if that's true, then what do? Who owns quality? Who owns it in our organizations? Is it testing? Is it engineering or dev? Is it the business? Well, the answer usually you get from people is everybody owns quality, right? And to some extent, that should be the right answer. Everybody should own quality because quality isn't an organization. It's not a feature, right? Quality is an attribute. It's an emergent property of software. It's either there or it's not. Everybody should own it. But I think the key word is should own it. Because oftentimes, if everybody should own it, actually nobody owns it. And we've all been in situations like that, right? Where everybody says, well, that's not my job. I build the software. I test the software. I define the requirements. I manage the process. I tell you what to do. Everybody's got a job in it, but nobody feels like they own it. I think that's actually an opportunity. And I think it's an opportunity for everybody in this room. Because I personally believe that software development is changing. It's changing radically, and it's changing quickly. It's not going to happen overnight, but it is changing. And you're going to hear a lot of that during this conference. Just flipping through and looking at the presentations and the topics that are being discussed, a lot of people are talking about that change, about moving to a more agile process, iterative development, leveraging the cloud, virtualization, blah, 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 blah. All these things are interesting things. What we have to figure out, though, is, and as a business executive, I'm always trying to figure out, is a new thing a fad or is it a trend? Is it something that, your CEO read about in some magazine on the plane and showed up the next day in the office and said, we need to put push technology into our website, using a very old example. And everybody said, why? Well, it's because that's what it says you got to do next. Or is it really a trend, something that's changing the way we work? I believe personally that the movements that I just described, not all of them are going to pan out exactly the way they're being characterized or represented, particularly by those that sell their products, right? But I believe there is a change going on. And there's an opportunity for us in this room to take a leadership role in helping move quality forward in that new environment. Nobody else is doing it. Nobody else owns it, I don't think. We can own it. And I don't care if you're an entry-level person, you're a senior person, you're a manager. I don't care where you are in the organization. Because in my experience, there's a difference between leadership and management. I've had a lot of good leaders that weren't managers. I've had a lot of managers that certainly weren't leaders. You can be a leader, regardless of where you are in the organization. So we're going to talk about that. I'm going to talk about what's happening in quality today and how you can play a part in what's happening in making quality better. I call that real quality because I think quality is growing up just like software is growing up. That's what I'm going to talk about today. But in order to do that, we have to understand a few things about software. I've learned through 20-odd years of doing this that there's some certain characteristics and aspects about software and how it fails and why it fails that if I understand and think about will help me decide whether some of those trends out there are really trends or are they fads, whether things that are proposed to help improve the quality of our software actually will help the quality of our software. And I want to go through a few of those, because if we understand those, I think we can put quality in a new light and a new context. So why does software fail? First of all, software fails because it's different. You can't see it, you can't touch it, you can't smell it, you can't feel it. It drives people crazy, right? How is it talking to people about your business? 20 years ago, it was worse. They say, what do you do? Oh, I'm in software. They go, yeah, okay, great. What's that? Oh, you know, it's that stuff that runs inside of stuff. Like what? Well, everything. Yeah, but really? Software is different, and that's important to know for some very fundamental reasons. First of all, the bugs we have, not all, but many, are design problems. We create software. Every piece is different than the other application we've built. Our problems are different than problems in traditional manufacturing and building of things, bridges, even microchips. Our problems are different. For the most part, their issues when we're constructing things are typically manufacturing problems. Are they all manufactured the same way? Did the screws, do they have the right bearing? Are the parts all manufactured in a way they'll fit together? Did we replicate that process in a way that we reduce the defects in the manufacturing process? That's not our problem. For us, manufacturing is easy. We just copy it. It's great. Well, some people copy it when they shouldn't, but we don't have a manufacturing problem. We have a design problem. Unfortunately, software came out of the engineering community. It was created as a way to automate and make flexible some things that we used to build into our computers. And unfortunately, the people who started developing that were mostly hardware engineers. And unfortunately, they tried to apply what they thought made sense in their world around testing late in the process, because you really didn't have anything early in the process, statistical process control, conformance and compliance to processes, and things like that. They tried to apply to this new world. Some of them worked, some of them didn't work so well, but all of them stuck around, right? We still have some of those attributes in what we do, in what we call quality today. But a lot of them, I don't believe, apply anymore. And we'll talk about those more. I always say we haven't yet identified the laws of physics for software. We don't know how to mathematically say anything about software in a way that we know for certain if we test to a certain level or we do anything to it when we build it, that it is going to be reliable to a certain level. And even worse, we can't take two things that we've tested independently and they work pretty good and stick them together and say anything mathematically about how they're going to work together. We haven't discovered those laws of physics, and they may not exist for our business. We may never be able to do that. But because we can't mathematically say anything about our software when we build it, we have to test it. And test it we do. I'm going to talk about testing in a second. The third thing that's different is we expect software to be general. Let me ask you a question. Has anybody ever tried to boil water in their toaster? Have you ever tried? I mean, shoot, it's self-contained. It's got a heating element. It's got a slot to pour the water. Why can't I make tea in my toaster? I hope. Has anybody tried it? Show of hands. Okay, good. I was going to have you carted out of here. Clearly in the wrong conference. Wind River's down that way. You don't do that, and you would never think to do that. And if you thought of doing that, well, maybe you belong somewhere else. But we do that to software all the time. We build software for a particular use or purpose, and then we reuse it somewhere else it was never intended or specified to ever work in. And we get mad when it doesn't work. Why didn't that work? Gosh darn it, I'm sending Microsoft a message. This is ridiculous. I can't understand why that didn't work. We do that all the time, and we expect it to work. We don't do that with other things. And last, back to the testing issue. We have a problem in testing. We can't statistically test our systems today to the level we need to say anything about their confidence in a mathematical way. I'll give you a great example. Here's a simple program. Adds two numbers, returns that number. If you have 32-bit integers, how long would it take you to add these two numbers if you tried every combination of those 32-bit integers and ran at 1,000 times a second. Anybody want to guess how long it would take to run that program and exhaustively test that little dinky program? Well, I did the math. I was a math major in school, and so I have a very exact answer, which is until the sun burns out. It would take a long time. Actually, I think it's like 67 years or something like that. It takes longer than obviously you would want if you told your boss, well, I'm going to guarantee you this program works. The boss goes, great, that's awesome. That's what we need. That kind of attitude here, son. How long, when will you think that'll be done? 67 years. Okay, you're fired. We can't do it. Think about the size of the systems we have today and how hard it would be if we tried to test them to even a fraction of the amount of input space and the outputs that it's going to see and say anything statistically. It's really hard to get quality from testing. So to some extent, you can't test quality in. We have to do other things too. The other reason software fails is it's really complex. And this is related to some of the things I just mentioned. The code sizes are huge. You know, Microsoft, I don't believe now, won't publish how many lines of code in Windows 7. They used to publish it, and you'd see a little trend and a track. I can tell you that someone did an analysis on Linux. I think it's the Red Hat version. The last version had, I think, close to 10 million lines of kernel code and about 190 million lines of other stuff associated with that operating system. So it's about 200 million lines of code. Nobody knows how big Windows 7 is. They were rolling right up the chain and then decided, wow, this is a silly statistic, which in some extent it is, because what does it really mean? But it's interesting how big our software is getting. And the more memory, cheaper memory gets and cheaper disk space gets, well, we just fill it with more stuff, right? So it's very complex. It's hard to get right. We connect it together with everything. As mentioned, we expect it to work with everything we've never seen. If it's a web app or it's on the net, it's supposed to interact and work with anything else that talks to it. And oh my gosh, if it doesn't work, we are not happy. We also expect it to change on the fly. Can you imagine if other things in our life changed on the fly? What if you were driving a car and the new model came out, and as you were driving, they moved the steering wheel up 5 inches all of a sudden? Boop! You know, bumped the tires down. Whoop! Car jumped down. The doors moved. Maybe 2 doors disappeared. What if that happened as you were driving your car? You'd go, this is crazy. But we do it all the time in software. It's extendable, it has plugins, it downloads stuff, it runs, and it's all expected to work. It's really hard to get it right. A good example is a browser. So on the left here's a really old version. I just keep this because it's so old, of a browser. A simple piece of software. Someone once told me to make things simple is really complex. And that's a great statement because it's so true in software. To make something easy to use and simple is really hard. On the right is a very high-level architecture of a browser. And it shows you all the pieces in it, all of which have probably millions of lines of code themselves. Scripting engines, virtual machines, network communication portals. Never mind all the other things it does just to navigate through web pages that it's presented as part of its application. Simple things are really, really complex. Reason number 3 gets to quality, and that's why we're here today. And that is that, in my belief, we sometimes follow very ineffective quality practices. We test very late in the life cycle, where it's really hard to test to any kind of level of feasibility or statistical confidence because of the size of the application by that point. It's very hard to reveal bugs and defects that are hidden deep in there. It's hard to cover that application. It's hard to do a lot of things when we try to test very late in the life cycle. We focus on process compliance. I got to tell you, I'm not a big fan of process compliance. I know, don't throw tomatoes at me, other things. When I was an engineer, I started as a developer. There were 2 people I didn't want to see show up in my office. One was the security guard, for obvious reasons. Probably my stay was over here. The other was the quality person. How many of you have experienced this? I'm sitting there typing away, hacking away. I've been up all night. I've had pizza. I'm tired. The thing is due in 3 hours, and I got to get this done. I committed to my boss. We got to ship tomorrow. And some poor slob shows up and sits down and says, I have some questions to ask you about your code. I go, questions? I I hope it does it work, because it does. I said, no, what process did you follow to document it? I'm like, oh my God, are you telling me? Well, we need you to complete that by noon so we can pass our internal audit. It used to drive me nuts. And I don't blame engineers. I don't blame developers. When that's the relationship you have with quality, then you view them just as a hurdle. Somebody to appease and get out of your office so you can get real work done. I actually think this talk is not about Agile, although I do believe that iterative development and Agile is kind of where development is headed. Elizabeth, who's talking next, is going to talk more about Agile. But I actually believe that Agile, to some extent, was created in retaliation of quality people. Developers got in a room and they said, these people are driving us nuts. We got to cut them out, right? And if you remember in the early days, a lot of people in Agile said you don't need testers. This is not right. It's not true. It doesn't work. Elizabeth will tell you about that next. But I don't think they were doing that maliciously. I think they were doing it because they said, we just got to get people to realize we just got to get stuff done. And the quality people, they are a hindrance to that. And we don't want to see them anymore. So let's create a methodology that we don't include them. It's a conspiracy theory I have, grassy knoll kind of thing. I don't know if it's true or not. Because we don't know where to do everything, we often don't think about risk management and how to apply our scarce resources where they should be applied. I'm going to talk about that a little bit later as well. And we don't use metrics well. We'll talk about metrics as well when I talk about real quality. Cost of failure, we've always seen the stats about cost of failure. I'm not going to belabor you with all, people died because of software, oh my God, and all this stuff, because it's happened. It's tragic. But I did pick out a couple funny things that I thought were interesting. Here on the left, there was a gas station that had a software glitch. Gas was 5 cents. They had a busy day. Busy day. It was an automated, unmanned station, so people just lined up. The owner was excited. Look at all the people. What's our marketing campaign? We'll get to marketing people in a minute. What's our marketing campaign? Why is this working so well? Oh, my gosh. Well, we're charging 5 cents. But we're going to make it up in volume. That's what we did in the internet age. We made it up in volume, didn't we? It worked. A lot of eyes on that pump. Good strategy. Didn't work so well. How about this poor guy, Josh? Right? He gets his visa bill. I actually had to look up, being the math minor that I am, how big this number was. 23 quadrillion, I believe, is the right number. How would you like to open that statement one day? Let's see what my wife bought this week. Oh my God, she bought Macy's and every other department store, all of them at once. 23 quadrillion. The best part is they charged them an overdraft fee. I love that. That's Visa in action, right? You just spent $23 quadrillion with them, and they want to charge you $15 because you're over your credit limit. These are the kind of things that happen in software all the time that need to be addressed. So what do we do about it? Well, I call it real quality. We've been working on a framework to say, okay, in the new world where we're headed, what's important and what's not? Let's get our hands around it. It's not a perfect model, but I want to run it by you and get your feedback. I'll be around the next couple days. Love your feedback on it. Let's start with the depressing news, and that is the current definition of software quality. Here's a couple of definitions that I just love. Quality is assuring the standards and process and procedures of our software and appropriate project are implemented correctly and appropriately, and have that by noon. Software quality assurance process of ensuring established guidelines, procedures, processes are followed, and have that by 11:30. So anybody want to guess why I really don't like these definitions? I don't like these definitions. Well, I just don't think that they're productive. I don't think they add. If you think about why software fails, the process is important, but it's not the full picture. And when we focus just on our process, we throw the baby out with the bathwater, in my opinion and in my experience. So what is a good definition? Well, I don't have a perfect definition, but I wrote one just because I felt like I should. I'm not even going to bother reading it, but I will pick out some key things that I think are important. First of all, activities are planned. Now, I don't mean big bang, plan it all up front, set a stake in the ground, and drive toward a milestone that 2 weeks from now doesn't make any sense, which is what is the role of product management. That's their role, is to do that. No, our role is to plan out and think through what needs to be done and what's appropriate, and then start working toward that. And as things need to change, we adjust. We adapt. That's my version of planning. Our role is to provide management information. They need to make decisions about the software. If we're building software, it is a business decision whether it gets released or not. It is our job to give them the information so they make good decisions. We don't control how well they're educated. We don't control, that's a way to say we don't control how stupid they are. We don't control, we've all said, what is that CXO thinking? How did that person get to that spot in life? Because they are a blithering idiot. We don't control that. We don't. So we should just live with it. Smile and nod. I call it smile and nod. But give them good information to make good decisions. If they don't make good decisions, we just can't. All we can do is try to give them better information next time. It's about the quality of the software. And by software there, I mean not only the code, but everything around it. That documentation that is necessary and needed for your process. The other things about the application itself, its environment, its how it's used, its relationship with users, its relationship to what's needed by customers. It's about the software itself. The documentation is important. The process is important. All those other things have some importance. But in the end, it's about the software. Does it work or not? We can fix the other stuff, but if the software never works, we never ship it. If we never ship, we never make money. And if we never make money, we all get laid off. It's a real simple transition, so we got to get that right. We want to make sure this is about business decisions. And one of the things I'm going to encourage everybody in here is to start thinking more like a business person. When you talk to management, you need to talk in their terms. Because if you do that and you start talking about the ROI and value and risk and reward of the activities you're doing in testing and ultimately quality, you will relate and get what you want from them more often than not. So my framework has 7 pieces, some of which are things you've seen a million times, and some of which are new things or emerging things that I'm going to talk a little bit about. This is I call it real quality framework. The components of quality. And testing is in here. It's under validation as we'll talk. Risk management. We don't have enough time to do what we need to do. We don't have enough time to test. We don't have enough time to do what needs to be done. We have to prioritize what we do. How do we prioritize what we do? I've had great success prioritizing by what is the consequence and likelihood of failure of the things I'm interested in, and prioritizing by making sure that the baddest things that can happen don't happen, and make sure that the annoying things, well, if they get released, that's okay. There'll be some people complain about it, but it's not going to kill anybody. It's not going to set the gas station up to give gas away for 5 cents. It's certainly not going to charge poor Josh $23 quadrillion. Software development's often tailored today. With agile or iterative development or lean or whatever the new methodology is that you're probably hearing buzzed around in your organization, adaptability and context-driven capability is the name of the game. You have to be able to adjust. And the best way I've found in testing and quality is to do that based on risk management. The other thing is the same amount of quality and testing doesn't apply. You don't do the same amount of testing for the space shuttle that you do for a word processor. You're going to do more for the space shuttle. There's more consequence of failure, and you got to make sure that never happens. So you also want to adjust your resources appropriately to do the right amount of quality and testing for the organization and for the market you're in. Verification. This is what I call old school QA. This is the compliance piece. We can't forget about it because there are certain industries where you have to have compliance because of regulatory or other aspects of the business, compliance aspects that market has. It might be government regulated, it might be industrial regulated. It's somehow regulated or controlled in a way that certain things need to be in place, i.e. documentation, certain procedures need to be followed, certain things still need to be done. And so we still need sometimes to do some of that. I would argue we often do too much of that in situations where we don't need to do it. So for instance, a lot of people say, one of the myths of Agile, you can't use Agile in a regulated environment. Really? Why not? Well, because Agile says you shouldn't document. Well, one, that's not true. But two is, what Agile says is you document as much as you need to get done what you need to do and get software out the door that meets the needs of the customer. If you can't publish or release software that hasn't met an audit, then that documentation is needed in any process you follow, and you're going to do it, whether it's Agile or Waterfall or whatever. I've been involved in projects like that where at the beginning we had huge pushback on following an Agile development process because we have to undergo Sarbanes-Oxley and it'll never pass. In the end, the auditor said, this is the best documentation that meets my needs I've ever seen. What great process did you follow that's so document-centric that created this wonderful documentation? And we said, Agile. And they were like, what? How did Agile produce that? It can be done and it should be done. So we can't forget about these types of things. But in my opinion, what we have to be careful of is what I mentioned earlier, which is following process for the sake of process. Back to why software fails. In my experience, oftentimes software doesn't fail because the one gold standard process that's been created by somebody or some organization wasn't followed to a T. That's usually not the reason it follows. And you know what happens when we often have a process that sort of works and it has some things that don't, and we institute a brand new process? Guess what we do? We throw away all the things that did work. And we often end up worse than we were before. So be very careful about process and how we deal with process. And I'll talk a little bit more about that and how you do it properly under this model in a bit. Validation is about testing and validating, but we don't want to just test the software. Don't forget about the other things that get produced, particularly in environments and processes such as Waterfall or others where there's a lot of upfront description and documentation of the requirements and spec and architecture of your system. Those things should be reviewed and validated way before we get to coding if we're following that process. If you want any hope of building software under that type of model, reviewing and analyzing the quality attributes of your requirements, your specs, and your other upfront docs is absolutely critical, in my experience, to ferreting out problems there versus finding all those issues when you get downstream and find out after you build it that your architecture doesn't scale and you need to re-architect the whole product from scratch. Very costly to find those kind of early life cycle issues through testing of the software. But don't also forget about other aspects of quality. We often forget about the non-functional aspects of quality, right? We think in terms of requirements and needs of the customer and use cases, things like that, but we often forget about the things the software shouldn't do. It shouldn't crash like this. It should work in the face of other things failing. It should be up and available. It should be secure. It should be fault tolerant. It should be testable. It's got to be built in a way we can actually test it. Metrics. Metrics is a dicey, tricky topic. I know there's other people discussing goods and bads of metrics. Let me give you my view. Oftentimes when I go into an organization and they're doing metrics, they're doing it all wrong. They're measuring things and they have no reason or goal as to why they're actually going to measure those things. Or if the measurement maybe makes sense, they're misusing it. I'll give you a great example, and this gets back to the quality compliance type example. There's some value in scanning your code and figuring out how complex it is. Studies have shown complex code, yeah, it tends to be buggier. But to take a metric like that and say any complexity value over 10 needs to be rewritten, now that's the kind of thing that starts to get developers a little edgy. When you start telling them, well, you need to rewrite this section because it's too complex. And the person's like, yeah, but I unit tested the heck out of it. I know it works. We borrowed it from somewhere else and it's been in the field for 10 years. And they go, sorry, that's the rule. I'm the quality person. And our rule is under 10. I need that by noon. That's the thing that gets us in trouble with metrics. But the thing that bothers me about metrics, and now I can bash on the marketing people, is when I'm a business owner and I have people come in and try to justify projects and things they want to do, Guess who does the best job of presenting what they do in terms of ROI and value and return and investment? Guess who does that? Is it the whiz-bang software development gurus with computer science degrees and math degrees? Is it testing with this equivalent? Who does the best job? Well, it's not sales, all right? We even beat sales because they don't believe in numbers, except the one that goes in their pocket. But marketing does a great job of doing that, and this is what frustrates the heck out of me. You remember the marketing people? They're the people we tutored in school in math. We tutored them in school. They were like, what's algebra? You know, why an X? I thought this was a numbers thing. What's with the X in here? These are the people we tutored, and they're outperforming us in numbers. Drives me nuts. We have to do a better job in metrics. I find the best way to deal with metrics is a mechanism down bottom, and you can look it up. It's a methodology developed by Vic Basili at University of Maryland called goal question metric, and it's real simple. It just says, figure out what the goal is of what you're trying to measure. What business objective or thing are you trying to show? And why is it important? That's the G. Think about then what questions you could ask of the software or of the artifact you're building or of the system that would, if you answered those questions, would tell you whether that goal's met or not. And then think about what metrics and measures and things you could collect about the application itself would answer those questions. Build your metrics top down from what you're trying to achieve and the goals of what information you're trying to provide, and tie those together, and you can build interesting, decent metrics. I'm going to get to metrics and defect tracking later because the easiest metric to collect is defects. And measuring defects is such a simple thing, and we don't really do that great a job of it. There's a lot of data in metrics or in the defects that we track. And we can use it in quality, right? We can make release decisions. How many defects are still being identified by testing? Is it tapering off? Is it increasing? How many have been fixed? How many criticals are still out there? What's our projection or estimation of when those two lines cross? When are we starting to converge on good software? That's interesting information that unfortunately I don't often see presented to management as metric data on helping make good release decisions. We should do that. Root cause analysis. So if we don't follow some magical process in the sky that's the best process you could ever follow and everybody should follow it because it doesn't exist, what do we do? Well, I believe you improve process by measuring the quality of the process. You don't just create a new process and declare victory. One, no one will follow it, but two is you don't know if it's any better, maybe worse than the last one. What you do instead is you measure what's coming out of the process. You check how good the requirements are, how testable, reliable, scalable. You look at what defects escaped detection. You do the same for your designs. You do the same for your code. And then you look back and say, where are all my problems coming from? Oh, all my problems are coming from my requirements. Well, I'm not going to propose to then change my design process. Why would I do that? I just need to focus in and fix my requirements process. It's where all the problems are. So use defects and root cause analysis to figure out where you can improve process and where there's value and benefit in doing that. And present that to management in those terms, business terms. There's ROI and value in fixing this piece of our process. Don't go in and say, hey, we're going to do a new process from scratch and we're going to create it and we're going to push it down on everybody. And I want it done by noon. Developers love that, right? We're moving to a new process. It starts tomorrow. But none of your dates are changing. You're just expected to just kind of pick it up and run with it. Shouldn't impact anything, right? This is one of the new things that many of you have probably heard about and been involved in. How many people are familiar with continuous integration at this point? CI, as it's called? That's great. I spoke at I got asked to come up to a quality assurance conference. And when I say quality assurance, I mean quality assurance. To talk about continuous integration. Oh, what fun that was. So I got there, and I said, yeah, sure, it's down the road, it's close by, I'll go do it one afternoon. Sounds great. I get there and I get up and I'm saying, okay, I'm going to talk to you all about continuous integration, how it fits into quality. How many people in the room have ever heard of continuous integration? Looking around, and they're like, there's nobody. Oh, no. Oh, there's a gentleman. Oh, great. Sir, what do you know about continuous integration? Well, I saw it on Google. Do you know the biggest quadrillion number is a Google? Just thought I'd throw that fact out there. I got Google into the discussion somehow. I said, oh, great. I was like, oh, boy, this is going to be painful. Because how do you even start with continuous integration and describing it and discussing it in any detail? And I had an hour to kill just about that subject when no one in the room has ever even heard of it. Said, anybody do process audits? Whew, I do. Everybody shot their hand up. I'm like, okay, I see what crowd this is. Continuous integration is hot, and there's a reason why it's hot, and it's a reason why everybody in this room should not only know about it, but in my opinion, should seek to own it in the organization. It is where development, test, release engineering, quality, management intersects in today's development process. It is the hub for an iterative, agile development process. It is the automation of all those nasty, heinous things that we have always hated to do, but needed to do, but never worked together. Controlling our source code, managing our builds, running appropriate tests, deploying and releasing our software, automating the collection of metrics and measurement into dashboards and giving information to the business. It's all of that stuff. There's great open source tools out there. There's great commercial tools out there. Everybody should be looking into this. We felt so strongly about this at Coveris that we built this thing called Secure CI. It's an open source tool. We cheated because we just basically took a bunch of open source tools and put them together. But we found whenever we went into an organization to do agile development, the first thing we did was set up CI because you need it to run your whole iterative development process and testing process. So we figured, well, if we do this every time, why don't we just put them all together? And if we're going to put it all together, why don't we just give it to the community? Because it's all open source stuff anyway. So if anybody's not doing CI or looking for something better, you can hit our website, download it. It's big. It's not a quadrillion, though. Not that big. But it's all set up, auto installs, all that crap. Get you set up, get you going as quick as you can. CI is something you need to know about. We're going to talk further about that in a minute. The last piece is another classic piece of quality that's hung around, that needs to continue to hang around, and that is configuration management. We often do a terrible job of controlling and managing the resources that we use, both in development and testing. Our documents, our test cases, our code, our scripts, our platform definitions and descriptions, our tools, everything we have, we need to control and document and define and control those things, and as they change, manage that change and upgrade of those entities. Otherwise, we get ourselves all confused. So the biggest one we see, obviously, is in development is source code control. I've seen code clobbered 1 million times by people who have not done a good job of maintaining or controlling their code, and people have made changes and branched them things and tried to merge it, and it all messed up, and they couldn't get it all right and had to retrack and spent countless hours, if not weeks and months, digging themselves out of something like that. It's very important. All right, let's get to the last piece of the talk. What can you do? I call it a wake-up call because I think the world is changing. Quality's changing. The good news is the process quality people, in my opinion, they're the dinosaurs of this industry. They're the dinosaurs. You look at where development's headed, iterative development, agile, continuous integration, all those types of things. There's not a big focus on that. The big focus is adapt and adjust, right? Don't plan and define everything up front. Declare a process, follow to the nth degree, regardless of whether you're going off a cliff or not. Follow what you think makes sense, put it in a risk context, drive it forward, and replan, change, adapt based on the situation and the market conditions. It's a much more market-driven approach. It's funny, when we come in, oftentimes engineering is like, Agile, 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 we love Agile, we want Agile, we want Agile. You get in there, and the business people are like, oh, Agile, sounds scary. Sounds like, developers are going to do whatever they do, and they're going to want to go home at 5 o'clock, and I hate that, and I want them to stay up all night. And so you start down that path. You get into Agile, and you see it start to shift. Business people are like, you mean I'm going to get working code every 2 weeks? You're like, yeah, every 2 weeks you'll get a piece of software that works, end to end. And you'll see it. You can try it, and if you don't like it, you can tell us what you don't like. They're like, really? Oh, wow. I usually wait a year. Every 2 weeks, you mean? Yep, every 2 weeks. Huh. I kind of like that. Developers are like, unit test? We have to do what? Unit test? I have to test? I'm a tester now? I thought Agile just meant I just did whatever I wanted. And we had kumbayas every morning and we got to go home at 5. This is not right. This isn't what I signed up for. How can this be Agile? That's not what I understood Agile to be. And you see it turn over time. And by the end, it's funny. In the end, they all typically like it. Development, though, is less excited than they were up front because Agile, if done right, is pretty rigorous. Rigorous in a good way, meaning it's rigorous toward getting software out the door and getting stuff done and adjusting as you go. Not rigorous in terms of following some stated goal and objective that you drive over a cliff and everybody knows it way before you get there, but you just keep driving. But the business loves it because for the first time they get things that work, they get it quicker, and they also control the release, right? Nothing worse for a business person when you're locked in and you're waiting for something from your development organization, your testing organization, and the world is zooming by you, changing rapidly, constantly. Your marketing is changing and everything's happening around you, and you say to your team, when's this going to be done? And they're like, oh, we still have about 4 months. You're like, yeah, but I need it out now. Our customers are saying now they're going to make a decision in the next week about which product to go for. I can't wait 4 months. You go, well, you're just going to have to go with what we got and just promise them we'll deliver something in 4 months. The world doesn't like that. Business doesn't like that. They want to go back to the customer and say, here's what we can give you next week. And oh, by the way, here's a plan for what we can give you every month thereafter. So it does make sense from a business perspective, and business people over time love it. So it is changing. So how do you act, and what can you do to move from your role on the testing aspects of what you do into real quality? I have some ideas, and then we'll wrap up. So the first is the easiest. Start from where you're at, right? If you're in testing, you don't want to jump way out and start trying to do things that you've never done before. You'd like to incrementally improve. I'm a big believer that if you're going to improve any process or any organization, you do that stepwise and incrementally. You don't just big bang some new process or some new idea and you just expect everybody to just jump on board and start running. Everybody's probably read Who Moved My Cheese, right? We know how hard it is to change people. People change slowly. Some don't change at all, but if you're going to get change to happen, it's got to be done slowly and incrementally. So what can you do? Well, I'm a big believer that you should be pushing really, really hard, regardless of the process that gets followed, to be involved as the requirements and specifications of your systems are being designed and implemented. And not just involved in terms of, getting to look at them so you can think about your test plans, but actually giving feedback and input into the quality and value and reliability and security of those requirements themselves. Now, I use test planning to do that. So sheep in wolves clothing, I'll go to the business analyst or the business side and I'll say, hey, I'm from the test group and, we want to make sure your product gets out the door on time, Mr. Customer. To do so, we'd like to start our planning early. So we'd like to look at your requirements as they're being created so we can think through testing of those requirements. Usually they're all for it, right? Oh, great. Somebody's going to start early, going to get it done quicker. That's great. That's a good way to get in with the requirements, elicitation, and definition process. Once you're involved in that, start sending back things. Hey, this doesn't make sense to me. What does this mean? I can't really figure out how I'm going to test this thing. Use testing and the testability of requirements and specs as a way to start asking questions and getting people engaged in improving those things with you in the process. You'll get some pushback initially, been through that many times, but once you start adding value to the process and making what they have better, you're going to start to win out and succeed in that battle, and you'll start getting involved early. And once they see your involvement in requirements, you can start moving into other aspects of the documentation process that is being followed and start doing the same types of things on other things that are being created. Risk management. Easiest place to start with risk management is in your test strategy and planning. You ought to be highlighting and emphasizing risk, assessing risk, and figuring out what are the most important things to do in my testing activities, which functions are most important or business critical. Those are things you should be talking to with the business about, prioritizing what's most important and what's most critical. And you're going to have to fight with that one because a lot of organizations are really bad at prioritization. So many times I go in and I say, okay, let's prioritize these things you have going. And they go, well, they're all high priorities. It's like, well, no. If they're all high priorities, then none of them are priorities. Well, there's other things that aren't on here. Well, like what? Well, stuff we haven't yet thought of. It's like, no. You have to prioritize. What is the one most important thing? If the building was going to blow up tomorrow, which one of these things do you want? You'll finally kind of grudgingly get them to, well, it would be this. But really, this other thing's important too. You just say, okay, I'm going with that. There's one. You got to force them to prioritize, and you got to use that to think through, how do I best test to make sure the highest priority, most critical things are done first in testing. It's also a great way to justify release. I've had people come into my office and say, we need to ship earlier. Testing's not done. What do you think about that? Well, if you haven't done any analysis, or you don't know where you stand, or you don't know your metrics on defects and risk, what do you say? You go, well, that's risky because we're not done testing, and that's bad. Well, is it bad? What's left to test? What's the value in that testing? What's the risk? How close are we? Are we still creating bugs, and is that escalating every day? Is it going down now? You have to have that data to have intelligent decisions when management shows up and says, I want to do something different than we had planned to do. And you know what? If you have that data, sometimes they'll ignore it, but sometimes they won't. I've had situations where boss came in and said, got to ship a week earlier or a month earlier. I said, well, here's the risk in doing that. Here's what's not going to get done, and here's what might happen in the field. And they go, oh, really? Huh. Yeah, we'll hold off. I really don't want to put that software out with that kind of problems in it. That's short-term stuff you can get working on today. Medium-term stuff, learn how to automate testing below the user interface. I think everybody, okay, I won't say everybody because there's always special cases. I think if at all possible, if you have the fundamental inquisitiveness, logic, thought process that makes you able to learn how to script and think about automation, and you're not currently doing that, I would encourage you to figure it out and learn it. Pair test with somebody or pair automate with someone. Do something to learn how to do automation below the interface, below the punching and clicking and defining tests at the user interface. That type of testing will become more and more important over time in any kind of a process, but particularly an agile one where you're being asked to test as features are being developed instead of waiting till the end of a process. I think you should learn how to code, and I get arrows thrown at me. Boo, 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 for that one. It doesn't mean everybody's going to need to, but if you're hedging your bets, and you want to not only protect yourself in the market, in your career, but also put yourself in a place where you have a lot more flexibility and a lot more capability, nothing you can do better, I believe, than learn how to do some coding. We were having a conversation last night at dinner, and we were discussing the fact that really, in an iterative, agile type model, you got to get on the same page with development. Development and testing often don't speak the same language. You have two choices. You either learn their language or they learn yours. And I can tell you which way that's usually going to go. I find that if I show up and I make it real clear that, yeah, I'm from testing, but I know code, I know architecture, I know design, I know these things. I'm not doing it, and maybe I wouldn't do it from scratch, but I can read it, I can understand it, I can ask good questions. All of a sudden, your world becomes a lot easier. The people that would give you no time of day because they viewed you as a hindrance to the process, all of a sudden want you to be their best friend and work with them every day. I've seen it happen time and time and again. As consultants, we come into places. First week, we're kind of the Bobs, right? You've seen Office Space. Oh, here come the Bobs. They say they're here to help us test. But, I saw that movie, Office Space. I know what the Bobs do when they get here, and it's not good. So they're a little wary of you. Start talking to them, ingratiating yourselves. You start understanding their product, asking good questions, digging into it, making suggestions how to make it better. All of a sudden, they're like, wow, these guys aren't like the Bobs. They actually seem like they're going to help. All of a sudden, the people that wouldn't talk to you, or you could, I'm so busy, I don't have time. They're like, my schedule's wide open. Come on into my office anytime. Let's chat. Anything you need, call me at home. It's amazing. You get all that by learning their language. If you can, I encourage you to do it. We talked about defects and metrics earlier. Defect metrics, to me, are the key thing. If you're going to focus on one thing to move forward on a metrics program, focus on getting your metrics right for defects. Get defects defined. Get metrics around their discovery, their rate of fix, the projections of estimated fines of those defects. Get those right. Then you can start talking root cause, what's causing these problems, how do we start fixing those particular process issues. All of a sudden, you're pushing your way back into process improvement, but you're doing it not by saying, you need to follow the process, you need to follow the process. You're doing it by saying, here's where our defects are coming from. This process isn't working for us. Let's go figure out how to make that better, and let's measure what better means over time. Let's demonstrate the value of doing process improvement instead of just complaining because our process doesn't work the way it was documented by somebody who's not even here anymore. Probably quit the week after the process was done, or was a Bob. I mentioned continuous integration earlier. I really, really passionately believe that everybody in this room should learn and know continuous integration, should download some of the tools, read about how they work, understand how they fit together. Spend time in this area. This is an area where you don't need coding. Scripting, yeah, scripting, absolutely. Understanding how software is built, sure. How it all fits together, yep. But this is an area that will be critical going forward. And whoever owns CI, to me, is going to own quality. Now let's get back to that, who owns quality? Who wants quality? Let's start with that. Do you think engineering wants to own quality? Developers? No. I don't think they do. They might say they do. They're not going to own it. First of all, they don't have the people skills. Spending time with engineers, we have a big advantage over them. We speak English. We communicate effectively. We are successful actually talking to people. It's part of our job. It's a great thing about testing, why I love it, is it's part analytical, part engineering / development oriented. It's part people. It's part communication. It's part interaction. We have such a huge advantage over the engineers. I'm working at a company right now. They hired some engineers from a big company, some developers from a big company. Guy was telling me, first day, team came in. Everybody was great. Got going. Next day came in. The dude's hair was like missing chunks all over his head. And he said, what happened to your head? And the guy said, oh man, I couldn't sleep last night. So I cut my hair with scissors. Where do you get these people? Where do you find them? But they're all in development. I'm convinced. They will not succeed owning quality and working with management, and they won't do it. Who's going to do it? Marketing? Okay, so they can beat us in metrics. They can't beat us in this. There's no way they're going to do it. Forget sales. They have no chance. Product management? No, too busy. Line of business? Not their thing. We can own it. We can take it. Learn about the tools. Learn how to get regression testing into CI. The great thing about continuous integration is if it's set up right, it runs all the time. Some organizations that do it efficiently, every time a new check-in of code comes in, CI server picks it up, compiles it, makes sure it compiles, makes sure it integrates in, runs unit tests on it, and spits out a report, maybe even a text or something that tells Joe or Sheila or whoever, your code didn't work. Go fix it. Pass the test. It's great. Go learn how to do that. Learn how to get testing into that process. It's critical. Seek to own this process. It's critical. All right, last point. It's about out of time. Always remember why software fails. Remember why it fails. Because if you remember why it fails, you'll remember why doing a process a certain way that somebody decreed from above, it's not going to help your software be any better. Start with the software and how it fails and why it fails and what happens when it fails. Collect information on that and use that to make good business decisions about improving quality. If you do that, quality will get better and you'll own quality and you'll really set yourself up well going forward in the future. So thank you, everybody. I appreciate it. If you have any questions, I'll be around.